So good morning, students. I think the audio and the video are clear. Is it clear?
Yes, sir.
Is it clear? If it's clear, please, some of you can tell me. Please
Yes, sir.
put it in the chat box. Is it clear? Is it audible? Okay, right. Okay. Okay. I'm not able to see your responses, but I think what I speak and what I show are reaching you properly. Right. Once in 40 minutes, this meeting will get disconnected automatically. And then please wait. I will restart the meeting again at the end of every 40 minutes. Please join in the same link, and the class will go on up to 12 noon. I will try to do as many problems as possible, and I will explain. And this meeting is recorded also, so that each problem will be cut into small pieces, and they will be posted in the group so that you can refer at any time, and that will be useful for you. So now we go to the problems in the chemical kinetics. So the first problem, for the reaction ammonia plus oxygen giving NO plus H2O. So this is the reaction given. So this is the reaction given. If the rate of disappearance of ammonia, rate of disappearance of ammonia is 3.6 into 10 power minus 3 mole per liter per second. What is the rate of formation of water? Rate of formation of water. So the question is very simple. The reaction is given. Ammonia combines with oxygen to give nitrogen oxide and water. So on the reactant side, when the reaction proceeds, ammonia and oxygen will disappear because the reactants are becoming product. So as time goes on, the quantity of the reactant will go on decreasing, and the quantity of the product will go on increasing. Now this chemical equation is given, and the rate of disappearance of ammonia is given. Rate of disappearance means, see, it is expressed in concentration per time. So mole per liter, 3.6 into 10 power minus 3 mole per liter is vanishing in 1 second. If that is the rate of disappearance of ammonia, what is the rate of formation of water? That is the question. So first of all, you should know to write the rate expression. The rate of any equation is equal to, see, if it is a disappearance, then put a minus sign. Minus d concentration of ammonia by dt. But you should multiply this factor with the inverse of the stoichiometric number that is introduced here. So it is minus 1 by 4 d by dt of ammonia concentration. This is equal to minus 1 by 5 d by dt of oxygen concentration, which is equal to plus 1 by 4 d by dt of NO concentration, which is equal to plus 1 by 6 d by dt of water concentration. So whatever may be asked, you may answer. If you know to express the things like this. Now what is given is minus d by dt of ammonia concentration is given, which is 3.6 into 10 power minus 3 mole per liter per second. So minus 1 by 4 dNH3 by dt is equal to water is asked plus 1 by 6 d water by dt. Therefore, d water concentration by dt is equal to this 6 comes here, 6 by 4 d NH3 by dt. Here you need not consider the negative sign because the rate itself is rate of decrease. So this is what is asked. So this is equal to 6 by 4. This is what is given. This is what is given into 3.6 into 10 power minus 3. So 3.6 into 10 power minus 3. So you can do this, and this can be 9 times 0.9. So this will be 54. Therefore, 5.4 into 10 power minus 3 mole per liter per second. Now you take down. Now we go to the next problem. For a reaction or giving product, the reactant giving product, the concentration of the reactant changes from 0.05 molar to 0.04 molar in 30 minutes. In 30 minutes, what will be the average rate of the reaction? It's a very simple problem, but this gives you the fundamental idea about the kinetics. So the reactant is becoming product. The concentration changes from 0.05 molar to 0.04 molar in 30 minutes. What is the average rate of the reaction? See, the average rate is nothing but minus, because it's decrease, delta R, that is the change in the reactant concentration by delta T. It's a direct substitution reaction. Delta R means minus R final minus R initial. Delta T is T final minus T initial, like that. So that is equal to minus R final is 0.04, R initial is 0.05, and the time taken for this conversion is 30. Therefore, this becomes minus of minus plus. It is 0.01 divided by 30. Therefore, this becomes 3.3 into 10 power minus 4 molar per minute. It is expressed in minute. Molar per minute. Is it clear? If it is clear, please put it in. No, you need not to speak. I am not able to listen to you. Just type yes in the chat box. Okay. So the next problem. See, in a reaction, 2HI giving H2 plus I2. The concentration of HI decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. This change happens in 10 minutes. What is the rate of reaction during this interval? This problem, as we did in the earlier one. So now the rate is equal to, this time you have to introduce minus 1 by 2 also. Minus 1 by 2 delta, that is the change of concentration of HI by delta T. So that is equal to minus 1 by 2. So what is the change? 0.4 minus 0.5, and this time is 10. So that becomes minus of minus plus. It is 0.1 by 10 into 1 by 2. So that becomes it is 1 by 100, no? 1 by 100 into 1 by 2. So it is 0.01 by 2 means it is 0.01 by 100. So 10 by 100, 0.05. So it is 5 into 10 power minus 2 molar per minute. So next problem. For a reversible reaction, A plus B in equilibrium with C plus D, I'm drawing a graph. So this is, let me say, concentration. This is time. This is P. This is Q. This is R. The question is, what do the terms P, Q, R say about? What do the terms P, Q, R say about? So P is not a concentration. Let me say this is a rate. So rate versus time. Rate. So P, as time goes on, the rate goes on decreasing. As time goes on, rate goes on increasing. And there is at a particular time, both the rates are equal. So P speaks about forward reaction. And Q speaks about reverse or backward reaction. R is equilibrium condition. R is equilibrium condition. P is a forward reaction. And the Q is reverse reaction. Clear? So fifth problem. This is also another interesting simple problem. Consider the reaction N2O3 giving 4NO2 plus O2. In this reaction, NO2 is formed. NO2 is formed at a rate of 0.0125 mole per liter per second. NO2 is formed at a rate of 0.0125 mole per liter per second. The question is, what is the rate of the reaction? Whenever a question is asked like this, first write the rate expression. Rate expression for all the reactants you write. The rate of this reaction is minus 1 by 2 d concentration of N2O3 by dt, which is equal to plus 1 by 4 d concentration of NO2 by dt is equal to d concentration of O2 by dt. This is the general expression. Now what is given is this. This is what is given. The rate of formation. So the rate of reaction is supposed to be, the rate of the reaction is 1 by 4. Then this rate has to be substituted. It is 0.0125 mole per liter per second. So it is 0.0031 mole per liter per second, or this can be written as, if you put a full stop here, 3.1 into 10 power minus 3 mole per liter per second. So this question can be asked, by giving the rate of change of the concentration of any of the three products, any of the three molecules which involve this reaction. So it can be either N2O3 or NO2 or oxygen. But once, if you know to write the rate expression in terms of all the reactants and all the products, whatever may be given, you can very easily calculate. So the next problem. Consider the reaction 2N2O4 in equilibrium with 4NO2. This problem is a little interesting. The minus rate of change of concentration of N2O4 is K, and the rate of formation of NO2 is K dash. The question asked is, what is the relation between K and K dash? So in these, if these problems are asked, then if you look at the four options, the four options will be K is equal to 2K dash or K is equal to 1 by K dash. If you look at them, you will be confused because everything will be looking alike. So in such situations, first you try to write the rate expression. See, there are people teaching you the shortcuts, but the shortcuts, we can never expect them to work out well all the time. But if you go by principles and logics, the principles and logics will never fail. So first write the rate expression. Rate of this reaction is minus 1 by 2. The D of concentration of N2O4 divided by dt is equal to plus 1 by 4 dNO2 by dt. So this is the rate expression. So this particular part is given. It is minus 1 by 2 K is equal to, this part is K dash. It is 1 by 4 K dash. For the matter of decreasing and increasing, you can neglect the sign. So it is half K is equal to 1 by 4 K dash. You multiply everything by 4 so that you can make this a whole number. So this will become 4K by 2 is equal to 4 by 4 K dash. So 2K is equal to K dash. So this is the relation between K and K dash. Sometimes it can be, the options may be given like this also. Say for example, this is also a correct answer. Answer can be K is equal to 0.5 K dash. This is also a correct answer. Or K is equal to K dash by 2 is also a correct answer. So answer can be given anyway. But if you write down the systematic procedure, systematically if you calculate, if you write the rate expression and do the calculation, then you can do well. So at the end of every problem, I'm giving you a few minutes to take down. So you take it down. Okay, I go to the next problem. See, for a reaction, ammonia giving nitrogen and hydrogen. This is a very famous reaction, the Haber process. The same reaction is explained in equilibrium, the same reaction is explained in kinetics, and the same reaction is explained in catalysis. The same reaction is explained for heterogeneous catalysis with the iron catalyst and the molybdenum promoter. The equation is very famous. Even the same reaction is taken for Lee-Chatelier-Brown principle. Now, the question is very interesting, but everything involves the principle what we have seen in the previous questions. Look here, the rate of decrease of ammonia concentration is K1NH3. And the rate of formation of nitrogen is K2NH3. Everything is written in terms of NH3 concentration. And the rate of formation of hydrogen is K3NH3. The question asked is, as it was given in the previous question, the relation among K1, K2, and K3. That is the question asked. What is the relation among K1, K2, K3? Again, as usual, go to the fundamental principle. You write the rate expression. It is minus 1 by 2 dNH3 by dt, right, is equal to dN2 by dt is equal to 1 by 3 dH2 by dt. So this particular part can be written as minus 1 by 2 K1NH3. So this particular part can be given as K2NH3. And then this particular part becomes 1 by 3 K3NH3. So NH3 is a common. Therefore, this equation can be rewritten as half K1 is equal to K2 is equal to 1 by 3 K3. So this is 0.5 K1 is equal to K3 is equal to 0.33 K3. If you want to make this number whole number, you multiply everything 3 times. So it is 1 by 5 K1 is equal to 3 K2. 3 K2 is equal to K3. So the answer can be given in any form, either this form or this form or this form. Suppose if you want to make K1 this coefficient whole number, you will get yet another answer. Just multiply by 2. What will happen? K1 is equal to 2K2 is equal to 0.6 K3. Like this. Answer can be in any form. Question may be asked in any form. What is the relation between K1 and the K2? Or what will happen to K1 when K2 is a 2K2? Like that. Answer can be of any form. But only thing is, if you are able to write the fundamental expression, then you can go systematically and you will get the correct answer. Clear? So we go to the next problem. The rate constant of a reaction A to B is 0.6 into 10 power minus 3 mole per second. If the concentration of A is 5 molar, if the concentration of A is 5 molar, then the concentration of B after 20 minutes. The question appears a little confusive, but it is a very easy question. So the reaction is given, A becomes B, and the rate is a 0.6 into 10 power minus 3 mole per second. If the concentration of A is a 5 molar, what will be the concentration of B after 20 minutes? This is the question asked. You look at the unit for the rate. It is a zero order reaction. It is a zero order reaction. So for a zero order reaction, concentration of A at any time is equal to initial concentration minus K into T, where K is the rate constant. So A minus A0, A0 minus A is equal to, this is initial concentration, this is the concentration remaining after time T. So A0 minus A is the quantity of the A reacted. So that's supposed to be the concentration of the B formed. You're supposed to understand. A0 is the initial concentration. A is the concentration remaining after time T. So A0 minus A is the quantity of A that is reacted. And that is the quantity of the B formed. Say, if you want to understand, suppose initially I take 100 molecules of A, and after time T, 80 molecules are remaining. Then 100 minus 80, 20 molecules were reacted. So these 20 molecules might have become 20 molecules of B. So this is the understanding. So the concentration of B is equal to K into T. So K, we know, K is given, which is 0.6 into 10 power minus 3 mole per second. So it is expressed per second, but here what is given is the 20 minutes. Therefore, this multiplied by time in second, 20 into 60, you will be getting 0.72 molar, 0.72 molar. So that is the answer. So the next problem. For the reaction N2O5 gas giving NO2 gas plus oxygen gas. A small technique you are going to learn here. Look at the reaction. It is N2O5 gas becoming 2NO2 gas plus half oxygen gas, the rate of disappearance of N2O5 is 6.25 into 10 power minus 3 mole per liter per second. What is the rate of formation of? What is asked is rate of formation of NO2 and oxygen. Rate of formation of NO2 and oxygen. The rate of disappearance of N2O5 is given, and we are asked to calculate the rate of formation of NO2 and oxygen. As usual, write the rate expression. Rate expression is minus d N2O5 by dt